Hello everyone. In this video we're going to write a simple Nasm program, hello world program. Okay, so let's get directly into it. So I'm going to use the micro text editor because, well, I like micro. Okay, so in every Nasm program we have three sections, which are the section.data, the section.bss, and we have the section.tex. The section.data contains variables which have already been initialized. The .bss contains uninitialized variables, and the .txt, which is a text, shows us where our code actually begins from. So here we write the global start, and then we begin with the start label or the directive. Okay. Also, because we're going to need some variables, we're going to say define the MSG to be, we're defining the byte, which is a dB, to be hello world. And for every string, we're going to conclude with, a null terminator and a new line character. This is the ASCII character for a new line. And this is the null terminator showing the end of the string. Okay. And also, we're going to calculate the length of the string. We're going to need that. So we're going to say message length EQU $-MSG. Okay. What happens is this is akin to writing the Python program like this. MSG to calculate the length. Okay, now in this program, because we are not going to have any uninitialized variables, we're going to take this .bss section out. Okay, and so here we're going to print out to the standard out. Okay, and how do we go about this? Well, we're going to have to place in 1 into the arrax, 1 into the RDI, the message into RSI, and we're going to have the message length into RDX. What happens here is these denote the following. That the placing 1 into the RAX essentially tells us that we're going to do a system write, okay? And placing 1 into the RDI essentially tells us that we're going to do, it's basically a file descriptor for the standard out. And here we're going to place our message, our pointer into RSI, and then the length of the message into RDX. And then we're going to invoke the kernel by writing the syscall. So think of it this way. Think of the registers here, RAX, RDI, RSI, RDX as like rooms in a hotel, and the kernel is going roundabout. And so when the kernel enters into RAX and he finds 1, or he or she, okay, finds 1, and then enters RDI and then he or she finds 1, the kernel once again enters RSI and then finds the message, and then RDX also finds the length of the message. Then the kernel knows that we're going to print it out to the standard out, or to the screen, essentially. And then after this, well, we're going to have to invoke the exit directive, which is we're going to have to move 60 into RAX. Then we're going to have to move 0 into the RDI. Then we're going to have to invoke the kernel once more, telling us that we've concluded. What happens here is this one shows us that we are making an exit request. Sorry. This one says, this is akin to writing a C program where, in the int main, we're going to have to conclude with a return 0. Okay. So essentially it's the same thing. So we're going to have to place 0 into the RDI. register. This very line is also akin to writing SOR RDI. Okay, the SOR operation, which essentially means that we're making the RDI value 0. Okay, so for example, why this works is, for example, if the RDI contains, say, 101, let's say 5, okay, and this 5 in base 2, sorry, and then we are storing it with itself, we have 101 underscore 2, then the SOR operation tells us that we're going to do a bitwise computation. So 1 plus 1 modulo 2 is 0, 0 plus 0 is 0, 1 plus 1 is 0. So it's essentially the same thing. It's either we are moving 0 into RDI or we are storing the RDI register. Okay, yes. And so after that, we invoke the kernel once more. So essentially the kernel is going to go about, and then kernel enters the room, the RAX room, and finds 60, and then the RDI, it also finds 0, and then we know that it's making an exit call. Okay, so let's save this, and then let's run this. I already have a script, so let's say hello world without the extension. The script you can find in the description. So it runs, no problem. So we run hello world. Then we see it's printed onto the screen. So it's not exactly anything quite difficult. Okay, another thing concerning this is the fact that sometimes we may have lots of things we would like to print to the screen, and perhaps maybe we have another message, say message 2, and then we are saying hello world, I don't know, pancake, okay, and we're saying 010 MSG2 length, we're saying MSG2, this is the length of the MSG2. What we're going to have to do again is we have to print out the MSG to standard out again. And so we're going to have to do move RAX1, move RDI1, move RSI, message 2, move RDX, message 2, and its length. And then we have to invoke another system call. Okay, so let's see. We run this, run this sh, then we run the hello world. You see, we have this, but sometimes it gets cumbersome. So what we're going to look at now is the fact that instead of always writing RAX, instead of always writing this for each, we're going to have to use something we call the macro. Okay, so you see the only changes in this is between the two of these. The only differences between these two is the fact that here we're going to have to insert the MSG, and also here we're going to have to insert the length. You see MSG2, and here we're going to have to insert the length. Okay, so we're going to have to create a new program that we're going to call, a document that we're going to call, let's say, macros.inc. Yeah, and in this macro.inc, what we're going to have to do is we're going to have it in the structure. Let me write it out first so we understand how it looks like. Sorry. 1, 2, 1 dx2, and then we invoke the system call, and then we end the macro. Okay, so for those of us who have been programming for long, it's quite easy to understand this, don't we? So it's essentially saying that whenever we want to print, we're going to use this as the name, the word print, and we're going to have to pass in 2 arguments, where the first argument is going to be our pointer, which is going to lie in the RSI, and our second is going to be the length of the string, which is going to stay into the RDX register. Okay, so let's save this, and then let's go back to our hello world. So now, instead of writing all of these, we are going to have to include our macro, where we're going to say macro.inc. Wait, did I call it macros.inc? Sorry, wait, let me look. Yeah, macro.inc. And so here, instead of writing all of these here, we're going to have to simply do print msg and then msg length. Here also, we're going to have to do print msg2 and then msg2 length. Okay. So we run our program. See. Then you see we still have the same thing. So macros really come in handy when you don't want it to always be verbose or cumbersome. So we can use this to, you know, compress writing our assembly code. And also, I'd like to say something concerning. Yeah, we can also do the same. Sorry, we can. This was called macros.inc. Yeah, we can also do the same thing for the exits. So exit, we can say we're passing in only one parameter, and then the exit, it was RAX. We're going to place in 60, and then we can say RDI %1. And then let's say we invoke this as call, and then we end our macro. Okay, and so we go back to our hello world. Then instead of all of this, we're going to have say, in fact, the program is going to be read from the top to the down, so we can take out this one, and then we can say exit 0. Okay, and the reason why I made it this way is because sometimes, let's look at my macros again, because sometimes we want to exit with a different number when there's a failure. So it's not always going to be 0. We can sometimes place in 1 when we exit, there's an exit failure, and 0 when there's a success. Okay, so we have this. Let's save this and try to compile it once more, and then run the program, and then it works fine. Okay, so there's the few things I would like to show you guys today.